Let us look at subgroups. Consider the group of symmetries of an equilateral triangle under composition of transformations, that is rotation and reflection. We have seen this in a previous session. Yes, so this is what it is. R means rotations and S means reflections. And this is the Cayley table for the group of symmetries. Now, are there a subset of actions which also form a group? So let us remove the actions S, R composition S, and R square composition S. If we remove this, then these three columns go off and these three rows go off. And we are left with this group, this subset of the entire set. So we have only the rotation transformations being considered, which means SR is equal to the set E, R square under composition of rotations. Remember, E means no action. That means leave it unchanged. Or we can say rotation by 0 degree. R is rotation by 120 degree. And R square is apply the 120 degree rotation and then again apply 120 degree rotation. That is 240 degree rotation. Now, if we look at this part of the group, then we have it is closed under composition. None of these elements contain anything other than the elements E, R square. It is associative. Identity exists, that is E. Inverse exists for each element. It is an abelian group. Okay, just to say that this forms a group, we don't have to look at the abelian part. This is just additionally I have mentioned. So here SR is a subgroup of S. S is the entire thing and SR is just this part of the group. So we say SR is a subgroup of S. Now here, remember, S is a subgroup of S. This notation is to show that the left hand side is the subgroup of the right hand side. Or in other words, a group is a subgroup of itself. And SR is a proper subgroup of S. So here we are being a little bit more specific than just saying it is a subgroup. When the number of elements is the same in both the subgroup and the group, we say subgroup. But when the number of elements is less than S, we say it is a proper subgroup. So when I say number of elements, it means what? It means the order of the group. So order of the subgroup may be equal to the order of the group, which is a trivial case, or it may be less. If it is less, we call it as a proper subgroup of the group. Just a set containing the identity also forms a group. So here, this also forms a group which just contains the identity element. So E is a proper subgroup of S, which is again a trivial subgroup. So the group itself is a subgroup of itself, and the group containing the identity only is also a proper subgroup. In both these two cases, we call them as trivial subgroups. S and E are called trivial subgroups of S. Formally, this is what we would say. Given groups H and G, H is a subgroup of G. When we say that, it means if two elements A and B are in H, then they are also in G. Identity is common to both H and G. We can't have a separate identity for one group and a separate identity for the main group. A and B belongs to H, then A times B, here times means this group operation. A times B is in H and A times B is also in G. A belongs to H implies the inverse of A also belongs to H. A and B are in H implies A times B inverse is in H, where B inverse is in both G and H. H times E is equal to G times E. So here, when I use the capital letter H to perform an operation, I mean that any element of group H, when composed with the identity, it gives a result which will be the same as the same element in G composed with the identity. H inverse is in H implies H is in G. Order of an element in H is equal to the order of that element in G as well. And just the identity is a trivial subgroup of G and H. And G is a trivial subgroup of G, which means H is a trivial subgroup of H as well. So that is subgroups. Now, as an exercise, what you can do is look at the various examples of groups that we have seen and try to identify the subgroups in them. That was subgroups. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.